Hi everyone, I am Dr. Vignesh Ponaya. So today I'm going to explain about modeling in construction, 2D, 3D and 4D. Okay, let us understand about what is 2D modeling is about. 2D modeling is a basic layout of a site in two dimensions. It does not include the dimension of depth. 2D plans can be created on paper or in computer programs. So when actually we can use 2D modeling? It is useful for broad overviews of sites, useful for conducting a high-level inspections and comparing large-scale changes over time, and give someone a simple overview of a site or project progress. While 3D modeling considered as a modern form of as-built documentation. 3D modeling always represented in the 3D model in XYZ dimensions. Some of the common software used for 3D modeling, such as Autodesk Revit, ISVE, and SketchUp Pro. 3D modeling basically used to visualize the object, recreation of complicated buildings areas, and to carry out other types of modeling work. Besides that, 3D modeling can also imported between other 3D software solutions. Let us look into the advantages of 3D modeling compared to 2D modeling. I have listed down four numbers of advantages. Number one, 3D modeling provide a better visual look compared to 2D modeling. Number two, development of 3D modeling will help the engineers during the design phase of construction, where it provides better interoperability and coordination between engineers. Number three, development of 3D modeling will also ensure availability of huge data for that particular building to be constructed. And finally, reduce overall construction costs and other related costs as well. Basically, for 3D modeling, the model has three different levels. Number one, model level. Number two, room level. And number three, surface level. Experience visual effects of 3D modeling. Okay, now let's find out what is 4D modeling is about. 4D modeling is considered as an upgraded version of 3D modeling. For 4D modeling, we integrate time-related information. This is to ensure a realistic simulation and easy access to all information, which will work in one place and works as a progress monitoring system. Basically, 4D modeling will be used for predicting future behavior and performance of the physical product. Okay, it will be better to go for an example of 4D modeling. I will go into digital twins. I'll be showing some examples of digital twin. Following a single building of digital twin created using ISVE taken from University of Glasgow. This is a digital twin developed based on Heriot-Watt University. This 4D modeling helps to quantify savings using real data from site and track performance of interventions. Virtual Singapore, a bigger scale of digital twin, created by the National Research Foundation (NRF), is a government department that offers 3D semantic modeling in which the meaning of data can be related to the real world, displaying land attributes or the characteristic of different forms of transport or the components of buildings and infrastructures. And apart from typical map and lane data, the platform also incorporates other real-time dynamics as well as information about demographic, climate, or traffic, it a tool that offers enormous potential and which can be used in many different ways. Let's go into more details using practical examples. I'll be demonstrating some practical examples using IES ICD software. So based on using this software, I will show how to import file from OSM to create 3D model, how to key data in for each building, how to view available attributes in 3D model, how to conduct simulation for each building from the 3D model, how to visualize the overall model, types and numbers of building in 3D model, how to create new building landscape, lampposts, trees, and photovoltaic in existing 3D model, how to conduct accessibility assessment, how to conduct walkability assessment, which can use to create bus stop, metro station, and bicycle parking. So this demonstration will eventually upgrade the 3D model into a 4D model. Okay, I'll be using SketchUp application for this demonstration. Create a file first. Once we created a file, we can open this OpenStreetMap to generate the data. So there's several options on your right. Are we going to include roads and pavement, landscape, and some other features of building or not? It's up to us. Okay, I'm selecting the location now. I'll be selecting Kompka Penang. Once you selected the location, we need to zoom the location. So you need to select the level of radius. Basically, we will use 600 meters. The more higher your radius, the more difficult or more will going to consume more time to extract the data. Before we start generating the data, please check your import option as well. Whether you just want to import the building information as stated there, or some other things. For example, you need to add in landscape, road and pavements, terrain, and other option as well. So once you confirm, you can start to import the data. So it's generating now. It will take few seconds actually to import the 3D models. So once we can view the 3D model, we can select the building. Yeah, we can select the building from the location, any building, where we can edit the information of a building. So based on the building selected, we can key in the data of building, for example, type of building, number of stories, height, space type, glazing ratio, and etc. The more data we key in, the more better will be the simulation result. We can also edit the HVAC service data, for example, type of HVAC service, envelope, ceiling door, external wall, external window, ground floor, and others as well. So it's all depends type of data that we are able to collect to key in inside the system. Okay, then once we check everything, there's sufficient to run the simulation, we can start the simulation. We can also add in water features. Then other optional details as well, such as building information, when the building constructed, location of the building, and etc. Okay, going to run the simulation. It's not going to be a full version of simulation result because we don't have complete data. Okay, so in the simulation option, we need to key in the target year, example 2021. We can also add in the weather data. Okay, we can select the weather file. Where's the location of the uh, simulation being carried out. For this location, I'll key in Kuala Lumpur. Okay, you can also run water calculation as well. Okay, going to launch. Yeah, it will take few seconds to generate the data. Simulation in progress. So basically, this software demonstrate how actually we can use 3D modeling to convert to 4D modeling. Okay, it's going to complete 86%, 92. Okay, done 100%. Okay, you can view the results. As I mentioned earlier, we don't have complete data, so we can't get complete version of simulation. Okay, but still you can identify total energy used per year. There's also a ready-made report that you can generate through the software. Okay, so based on the ready-made report, you can generate building types, construction dates, energy use intensity distribution, monthly site energy consumption, annual site energy breakdown, and other things as well. Okay, now let us see how to change the attribute visibility. Okay, you can actually add in available attributes to our simulation work. Okay, whichever attributes that you want to view for your results. We can also visualize the location. Okay, show some example here. So you can visualize based on buildings, type of building, so when you apply, you can view it. You can identify how many of office are there based on the location, uh, single story building, whichever type of building that you want to view. You can change the dashboard based on your uh, needs. Not only that, you also can check other items as well. For example, EV charger type, lamp type, object type, road type, and so on. So it all depends what type of information actually you want to view. Okay, this is actually to identify number of stories. Okay, so you can see based on this location, the top is 68 story, the lowest is 1. Okay, we also can create new building based on this software. Okay, so I'm creating a building. Okay, before you create a building, you need to make sure that what are the things that you want to key in for that building, especially number of stories, building type, roof, uh, roof angle, and so on. Once you identify, you can develop the building. You can see the building. Okay, you can also create landscape. Not only building, you also can create landscape. Okay, Okay, what type of landscape that you're going to create. You can key in, and you can key in the optional details as well. Okay, so I'm creating the landscape now. Okay, not only that, okay, there are some other things that you also can create. For example, lampposts. I'll show you how to create a lamppost. Okay, you can see street light. So based on the street light, we can key in type of street light, power, uh, profile of use, and other things as well. So I'm creating street light now. I've created three now. You can see three street light there. You also can create trees. There you can check which category of trees that you want to create. Okay. Also PV. Okay. You can also create PV. So I'm creating a freestanding PV on top of the roof. So there's a lot of option available actually to recreate the model, which fulfill the concept of 4D modeling. Hope you enjoyed the lecture video. Thank you.